Hello guys, and welcome back to my YouTube channel. This video is part of our tutorial series on C++ standard template library. Before starting the STL directly, we first saw some basics of templates, and we see some example of function templates and class templates. And in our last video we saw some examples of class templates, and we end our previous lecture at default parameters in template classes. As you can see here, we define the default data type to this class U template. Now we will continue our discussion on templates. One thing you will notice that these function templates are somehow similar to the function overloading concept. Function, in function overloading we use the same function for different type of tasks, and we use templates for the same reason, but there are some differences between these two. So let's see these differences first. Both function overloading and templates are examples of polymorphism feature in OOP. As you guys can recall, polymorphism mean many forms, so both of them can do various tasks, have many forms. Function overloading is used when multiple functions do quite similar but not identical operation, while on the other hand templates are used when multiple functions do identical operations but they have different data types. So our next question is, what happens when there is static member in template class function? Then each instance of templates contain its own static variables. So next we have, what is template specialization? Template specialization allow us to have different code for particular data type. Next we have, can we pass a non-type parameter to a template? Now this is a very good question. We can pass non-type argument to a template. Non-type parameters are mainly used for specifying max or min values or any other constant value for a particular instance of a template. The important thing to note about non-type parameter is that they must be constant. So they have to be non-changeable, non-editable, and a constant variable. The compiler must know the value of non-type parameter at compile time, because the compiler need to create function or classes for specified non-type value at compile time. Now we will see an coding example of non-type parameter to a template. So let's open my code editor and delete our previous code. We will write a generic function that will accept an array and will return us the minimum element from all of the array. So let's code this function. It will accept two arguments. First one will be the array, and second one will be an integer. Then we will write our for loop for iterating throughout the array. And it will compare each value to check which one is smallest. It will compare it to our this constant m max, which we will define during this function call. You will see that in a minute. Then it will return us m. Now inside our main function we will define two arrays and their size. Time for the size of AR1 divided by size of now it's time for our second array. It will be of character type. Now it's time for our function call. First one will be of integer, second one will be a constant. Let's say we give it 1000. Now it will compare the every element of this array to this 1000. Then we have our first argument will be our array, and second one will be the size of array. Now our second function call for character type array. Now let's run this program and check out the result. The result should be, first one we will be displaying 10 and then we will be displaying 1. So as you can see, our first result is 10 and second one is 1. So basically what's doing here is this template class is accepting a non-type parameter which is this constant 1000, and in second case is 256. What this function, what this for loop will do, or this AR min function will do is it will compare every element of the array that will pass to it as an argument to this second template argument, and will calculate if it is greater than or smaller than this constant. So then if it is smaller than, then m will be initialized to that in array's value, and this will be going on until we iterate throughout this loop. Then we will return our smallest value as a return call from this array min function, and then we will print it out. So I think that's pretty much all you need to know about templates. But before moving on to the standard template libraries, I want you to clear some little more concept, and one of these concepts is generics. So we will see some basic definition of what generics are in C++. Generics is the idea to allow type like integer, string, etc. and user defined types to be a parameter to a method, class and interfaces. For example, class like an array, map, etc., which can be used using generics very efficiently. We can use them for any type. The method for generic programming is implemented to increase the efficiency of code. Generic programming enables the programmer to write general algorithm which will work with all different data types. So basically generic means you write a simple basic code or algorithm, and any type of data can access this algorithm without any error. So it eliminates the need to create different algorithm if the data type is an integer, string or character. The advantages of generic programming are code reusability, mean you just write one, as we have seen in templates. So basically templates function are a type of generic programming or a generic function. You simply write one function, and every data type like int, double, or let's say float, or we can have a character. So mean of saying is that you write one function, one generic template function, and every type of data can access this function. Because you guys know C++ is very type oriented programming language. On the other hand, when we use some scripting language or like JavaScript, or a backend language like PHP, they basically do type handling by themselves. You don't even have to define the data type. For example, when you define an array in let's say JavaScript, you simply give the array name and define the element values. You can add integer, you can add character, you can add strings, you can even add other arrays into this. So basically JavaScript handle all type of data type handling by themselves. But on the other hand, in case of C++, we have to take care of data type by ourselves, because it is very memory oriented programming language. So we have to define these little things in data types and do all kind of that stuff. But on the other hand, C++ allow us to use these generic programming principles to tackle this kind of problem, and write only a specific piece of code, and it will allow us to use different data types. Then second, we have to avoid function overloading, and third one's written it can be used for multiple times and cases. Generics can be implemented in C++ using templates. So we have seen templates in our previous 3 video in a detailed manner. Templates is a simply and yet very powerful tool in C++. The simple idea is to pass data type as parameters, so that we don't need to write the same code for different data types. So we have seen this the examples of template in detail in our previous 3 videos. So then we have generic classes using template. We have seen example of both generic functions and generic classes. So that's all from today's video. In next video we will finally start our discussion on C++ STL, and we will see some examples of STL too. So don't forget to like, share and subscribe our channel, and keep supporting us for so we can make some awesome stuff like that for you. And thanks for watching.